Yeah, so my name is Darius, as you can see on the slides probably. My first talk in such a unconf, so I'm a little bit excited, but I hope you like it. And feel free to give me feedback later on how what to improve. I will be talking about seeding in a microservice architecture. So let's just jump in directly. Some pieces. Oh, I see it really small there. Okay, so some information about me. So I'm working at Darius, one of our sponsors. If you can prefer to give me feedback in a digital manner, just write me on Twitter at Darius Murawski. And I'm a developer at Darius since September 2014. And short notes about Darius itself. So we are a B2B search engine, and our main office is also here at Hamburg. In general, what you do when you do seeding, you do RakeDB seeds. So who used this command in the Rails application? Yeah, so you use it quite a lot. We also used it. So this is how we started our architecture as I started at Darius. So we have two systems basically. One, the SAP system you see on the left side, which is quite beautiful. And the second one, which we now call Core, our old monolithic application. So how it worked, SAP write a huge JSON file out of their database. Then we removed every data we have in the Rails application, read the JSON file, imported the data to the database, and updated our search index. And this was done each day, so it was really time consuming. And when the JSON was corrupt in some pieces, we get a lot of errors. But the good point is seeding was easy. So you just have to write RakeDB seeds, as I already showed you, and it worked. Then we started to using microservices. So the first app was extracted, and the second app, and then it looked like that. So we extracted the entire search logic, which was also part of the old core application, into an own app, which we call Search App. And the changes that were done in the old monolith were published using AMQP. And the search app was listening for these changes, fetching the data into the own database, and also updating the index. Unfortunately, the search app itself had no data at all. So to get you some seeding data, you have to start the AMQP worker by yourself, and then run RakeDB seeds in the old application. Then the data gets published and then consumed by the search app, which was already quite complicated. You have to know the process, and when we get new developers, we also have to show them how to do it. It was not that easy for them at the beginning. And of course, the architecture gets even more complicated. So we extracted even more applications, one for handling our company's data, one for handling our product data, and also for some media images that we transfer, so downscaling images and stuff like that. Each of these applications also produce MQP messages and were consumed by the search app to have the appropriate results. What's my time? I think I'm good. Okay. 5 minutes just. If I'm too fast, just give me a hint. I will try to slow down a little bit. So, what else? We get even more apps. I will not show you the entire structure, but because now there are 13 apps in total, and it's a lot of mess, cross-communication all over, and that was even harder to getting to seed, because you have to seed it in the appropriate order and have to run everywhere the workers, and it gets really complicated. And then we get the problem that the data got inconsistent over the several seed files in the several applications. Sorry, microphone. And we need a better approach, because this did not scale at all. So we define some requirements we want to have for seeding. We call it global seeding in our company. It should make sure that the data is consistent over each application that we are using. Also, the consistency of all models by themselves should be present. So when you have an association between, for example, product data and the company, we should make sure that when we connect both together to have this association, that the company also is present in the company data. And yeah, we want to have it easy extensible, which I will show you later how we achieved it. And yeah, we only want to make sure that you really have to seed or run RakeDB seed in that application that you are currently running, what you want to develop new features for. And not be dependent again on workers that have to run and fetch the data and do all this stuff. So how we achieved it? This is the first step we did. So we created a module. No, I'm joking. So we created a gem, which we call internally VLV seeds. And we generated a model class, which under the hood used the Virtus model. Who have worked already with Virtus model? A lot of you, okay. So Virtus model allows you to basically transfer the hash you pass in as a method later on. So the hash access is a little bit simplified. And for the space model, you have to implement an all method where you put then your really concrete data all in. And this is, for example, one of the models for the product application. So you define the attributes as the appropriate type. So this is a feature of Virtus when you don't know Virtus. And then you have to implement this all method. For example, I implement here, it's just a collection. And then you pass a method that's called, again, in the product scope, that then builds up the entire data for you, put it together. The method itself looks like this. So yeah, you just get the different IDs that are constants inside the seeds gem, and sometimes they are lists, so you iterate over them and combine them together to include every data you need. And then I grab my mouse. Where is it? No mouse. That's bad. Have we a point or something? So you can see there is one model which is called product category, and this is basically how we define associations. So for each model itself, you have a class method. In this case, test Schrauben, which is test screws. And on this method, you can call ID, because it's a Virtus model, and get the appropriate association built together. So this is an easy trick to make sure that the data is consistent. And when you change the ID in the product categories model, then it also gets updated in the connection that's using it. Again, searching my mouse, there it is. And this is, for example, the implementation in the product category model. So you call new on it, and also passing the seed data you want to have for this category. In this case, the name of the category in different languages. And we have also some full name stuff for SEO optimization. And as these product categories are built up in a tree structure, you can define the parent ID, which also then is a reference to another method that implements the ID of the appropriate model. So this allows you to also define some tree structures, which is not possible when you have cyclic dependency, of course. So this will just result in a Stack Overflow, which you don't want. So you have to make sure that your data is not cyclic defined. But I think when you're using relational databases, you also have to make sure that your data is not cyclic. Yeah. And are we done now? Did it work? Unfortunately not. which I have here. There is still some downsides. So the basic idea of the implementation I showed you would have the downside that you have to update the gem each time you added new seed data, which is somehow not what you want, which is quite heavily to maintain again. You have to update it everywhere, and you don't want that. Also, it does not really fit when you have different branches you want to have different seed data for, and how you handle that. So what we did, we created the client, which is using this data. So the seeds themselves are generated on our CI server and just creating a huge JSON file with the entire data in. And the client then fetches this data from our CI server and allows you to parse it. And of course, you have then to map these general data to your appropriate application structure. I just show you a little bit more in detail how it looks like. So this is, for example, the search application. You instantiate the logger instance, and then you just say to the client, please give me all product data, which will then result in a huge array with hashes, with all the data in a consistent way. And then you say, okay, now I start to create the appropriate instances of the model and start to iterate over the entire product data and map the data that's in the seed style to your appropriate application style. What I found out is that we have the same data, but modeled in different applications in a different way. So you always have to, unfortunately, map it somehow to the correct application structure there. So this is basically the idea of it. And I'm really fast, just need 20 minutes. So that's it. Thank you.